Measuring the speed of light is a pretty complex process.
But don't worry, we can break it down into simple terms, or I guess we should say the wise guy can break it down to a science. Good morning again, Matt.
Hi, guys. Okay, so in the last segment, we did something that was actually pretty simple. We measured how long it took a pulse of light to go through a known distance, and then we just divided that distance by how long it took, and then we figured out what the speed of light was. The speed of light, incidentally, is 300 million meters per second, which is equal to about 1 foot every billionth of a second, or nanosecond. And that's what we saw by using this oscilloscope, because we saw the little pulse moving over a tiny bit as we move the mirror away from the laser source. So what we're going to do now is we're going to show that light actually moves at a different speed, a little bit slower, if we send it through this beautiful piece of quartz that I have right here. Isn't this pretty? This piece of quartz is used in, or we used it in some research which has nothing to do with the speed of light, but it's quite stunningly beautiful. So I'm going to put this thing right down here, and Professor Kwiat is going to align this thing up so that now the... Oh, actually, maybe we should look here first. So let's if we lift that out of the way, you can see where the laser pulse is arriving right now, and when he places the quartz bar in there, you're going to see that suddenly the laser pulse, the detection of the laser pulse has been delayed by about 2 nanoseconds. So right now you see that in order for the light to go the very same distance, but now when it's going through this little piece of glass as well, that it takes another couple of nanoseconds. That must mean that the light is moving slower inside this piece of glass. And the fact that light moves slower inside medium other than vacuum or air, like a piece of glass, is behind all of geometrical optics. It's what makes lenses work. It's what makes that camera work right there. It's what means it means we can bend light and focus light and do all kinds of interesting stuff with it. So there you go. Now we've measured the speed of light in air in this room, and we've measured it in a piece of glass. Okay.
Hey, Matt,
yes?
let me ask you real quick. You said 2 nanoseconds just by going through that quartz. Well, does 2 nanoseconds really make a difference? What kind of impact can that have in terms of science?
Oh, it has a huge impact, because what it means is that the light is actually moving about 30% slower inside the glass than it is through the air, and that is what gives rise to the fact that we can make lenses and we can bend light, because if you send it into a glass surface at an angle, that means that the light actually bends as it enters the glass because it slows down a little bit. It's dragged down and it changes its direction, so that's very, very important. Okay, so I have a little next week we're going to work on the speed of sound, actually. It's kind of interesting, so people can send me suggestions for measuring that. But I want to give people a little quiz. This is a mystery tube, and if you can explain how this works, you can get a t-shirt. So I have here a string that's attached through the top, and I pull it like this. Very good. But notice, if I pull one of the strings at the bottom, it also makes it pull in. See that?
Wow.
So now I want anybody who's watching right now to send me an explanation of how this thing works, and whoever sends the best explanation is going to get a t-shirt.
All right. What's in the mystery tube?
That's making it do that. All right.
That's interesting. All right, Matt, thanks for that. Now, if you have questions for Matt, you can send them into the Wise Guy email. You can send wiseguy@uiuc.edu, or you can send it to us. We'll pass it on the morning show at wcia.com, or leave a message on the morning show feedback line, 373-3661. Also, check out the Wise Guy's home on the web, wiseguy.net. Stay with us. We'll have your weather on the 3s when we come back.